Start that up. Wait. Start a new note here. All right. So, just as a quick review, hopefully you managed to do assignment 2 last Tuesday, right? Otherwise, you'll want to buckle down and get assignment 3 done for next Tuesday. But as a quick review, right, we handed out the formula sheets, and believe it or not, we went through all the merchandising formulas, right, and so some key formulas. So we started merchandising. And covered some key formulas, right? There's more, but the key formulas we noticed were S is C plus E plus P, right? That one came up a lot. Okay. The net price is the list price times 1 minus D1 times 1 minus D2, all the way up to discount K. We talked about the ROMU and we talked about the gross profit margin. So ROMU and the gross profit margin. We have 2 formulas for each depending on what information we have, right? And then we talked about the reduced selling price is the original selling price times 1 minus the rate of the markdown, the ROMDA. Okay. And like I said, merchandising is definitely going to be on test 1, and it's one of the long answer questions on the final exam. Okay. So merchandising is on test number 1, and one of the long answers, one of the long answer questions on the final exam. Bless you. So you want to make sure that you have that under control, right? It's a little bit different than what we've been doing, but it's also kind of fun because you're given some information and it's more of a puzzle trying to figure out, okay, what are the steps that I need to do? And usually it's more than one step, right? And so you kind of have to massage it a little bit. But any questions about merchandising before we go on? Okay. So, section 3.3 is called business economics. On your formula sheet, it's called CVP Analysis. And I always forget what CVP stands for. And I want to say cost, value, profit, or price, but I'm not 100% sure. That's for you to know. That's not for me to know. All I know is that it's profit functions. Okay. So I'll put that here. It's essentially profit functions. Oops. Profit functions. Oh. So a profit function, if we think about it, right, a profit function is, well, just a formula that's going to tell us how much profit we're making, which if you break it down is just going to be the total revenue, right? All the money that you've made minus your total costs, right? Everything that it costs you to make that money. And then everything else is profit, right? And so what you'll see is we'll introduce all of these components in the CVP analysis section. I'll introduce them kind of from the top. But then what you'll find when you're doing the calculations is you're actually going to start with a profit function that's down in the lower right-hand corner, and then kind of snake your way through these formulas and pick up and build your profit function. But first, let's talk about just what is FC, what's BC, what's TC, all that fun stuff. Okay, so FC is the fixed cost, which you might have guessed. And I'll just make a little note here that the fixed costs are independent of the amount of output. Right, so fixed costs are things like your rent, the people you pay, right? You have to pay them even if you're not producing anything. As long as they're showing up, you have to keep paying them. Cell phone bills, right? Those types of costs, they don't care about whether you're selling stuff or not. If you've signed up for these services, then you have to pay for them, right? So those are fixed costs. And then on the other end, oh, what? My pen, I guess, clunked out. Hope it's charged. Phew. So the variable cost is denoted by VC, so that's the variable cost. Variable, remember, means just it changes, right? Or it can change. So this is the cost that it is associated with producing each unit, right? And so if you require materials, right, you have to use some set amount of materials. If you're working on something, right, your hourly wages, right, if you're employing yourself, those would be variable costs, right? And so variable costs, oops. Variable costs, not very helpful, vary with the amount of output. Vary with the amount of output. Right, and the output is just how much you're producing, right? Or for simplicity, in this course, we'll assume that if you make it, you'll also be able to sell it, right? And so we don't have that kind of, oh, you made too many and then now you haven't sold them, right? So for us, just to simplify things, we say, okay, making them is the same as selling them, okay? Which isn't necessarily true, right? TC is the total cost. Which is just going to be your fixed cost plus your variable cost. So your total cost is all your costs together. There are no other costs, right? They're either fixed or they're variable, and those are your only options. Okay. So we say that the total cost is the fixed cost plus the variable cost. And I'll throw a box around that because it's on your formula sheet. In fact, it's the first one. I mean, variable cost plus the fixed cost is the same as the fixed cost plus the variable cost, right? Okay. Now what we're going to do is we need some way to denote how many units we've sold, right? And so we're going to denote those by a lowercase x, just because we're going to be able to plug in some value of x and figure out what our profit is. Okay. And so I'm going to say let x be the number of units sold / produced, right? Because we're going to assume that that's the same thing. And let C, capital C, be the cost to produce each unit. That leaves us with the variable costs, right? Takes into account all the costs to produce each unit multiplied by the number of units. And that's also on your formula sheet. Okay. So then, moving on, we've handled all our costs, right? Variable costs, our fixed costs, our total costs, right? And so now let's talk about our total revenue. So TR is the total revenue, right? Total amount of money that you made. The total amount of money made, okay, which is the number of units sold, which is your X, times the price, which we'll denote by a lowercase p, at which they are sold. So I'll just emphasize that new variable there, letting lowercase p be the price. Maybe I'll say the selling price. Selling price of each unit. We find that the total revenue is P times X. Which is also on your formula sheet. So now we have all our components, and like we said, the amount of profit is going to be the total amount that we make, right? The total revenue minus our total costs, right? And so the profit, sorry, I bunged that up. The profit is the difference between the total revenue and the total cost. The difference between the total revenue and total cost. Now, because profit is a function of X, the number of units sold, we usually write profit of X is the total revenue minus the total cost. And this is also on your formula sheet. So what you can do is you can figure out each of these components individually, right? Or we can just develop a general profit function. And so what we're going to go through and do is we're just going to plug in everything that we know into that profit function and just kind of bake them all together. Notice that that's not on your formula sheet, right? And that is something so that you'll be able to do on your own, hopefully, on the test, right? And so knowing that the profit of X is total revenue minus total cost, we can expand this to derive a proper profit function. Now, because there's a page break here, I'm going to start down here and say profit of X. We'll start with the total revenue minus the total cost, right? That's on your formula sheet. Okay. And then what I'm going to be doing, working my way kind of counterclockwise around this sheet, or at least kind of snaking my way through, right? I'm going to plug in first that the total revenue, I can replace the total revenue with P times X. I'll just do every little step just to outline, but of course you don't have to show this many steps. This is just so we can work through it together. So next thing I'm going to replace is the total cost. I'm going to replace that with the variable cost plus the fixed cost. So this is going to be PX minus the variable cost plus the fixed cost. Be really, really careful here because we have minus the total cost, right? And so the total cost here has to be in brackets. Otherwise, you're going to lose this negative on here if you don't put brackets around it, right? Or you have to remember to put the negative inside. But I've done enough marking to know that you won't remember. Okay, so just put brackets around it and make sure that you bring that negative inside. Okay. The next thing I'm going to do is, because I know I can replace the variable cost with C times X, right? And so I'm going to do that before I expand and simplify. So I have PX minus CX plus the fixed cost, still in brackets. So now I'm going to expand this, which just means bringing that negative inside the brackets. And so I have PX minus CX minus the fixed cost. To simplify it a little bit more, what I can do is I can pull out that common X from PX and CX. And so what I have is X times P minus C, and then minus the fixed cost. Okay. I'll put this in green because it's not on your formula sheet, but it is a really handy one to know and to be able to kind of work your way to. Okay. Because depending on the question, right, we might want to start at this point or even up there. And so it's good to be able to kind of work through this pretty quickly. Right? This is the general profit function we will use. So like I said, it's not on your formula sheet, but you have all the components to build it, right? So let's do example 100. Okay. So Alienware Computers sells computers for $1,000. Production costs for a computer total $250. Okay. Rent for Alienware's office is $10,000 per month. Determine the monthly profit function for Alienware Computers. Now, it's assumed that each of these values are per month, and so that's why it says monthly. Compute the profit resulting from producing 12, 13, 14, and 15 units, and use those to determine how many computers must be sold before Alienware makes a profit. Now, I don't think I do that. I think I only do 12 and 14, and then I got bored. No, you'll see why. It's doing the same thing over and over again. So I do a little shortcut here. Okay. But first, we can develop our profit function. So, right, because we want to know, compute the profit resulting from selling 12 units, 13 units, blah, blah, blah. And so we want to build a profit function. And so we're given, all right, what do we have here? We've got P, right? This is the price per unit. P is 1,000. And production costs, so C, I'll put it up here, C is 250. I only see one fixed cost, that's the $10,000. Sometimes it'll be like, okay, they have to pay rent and they have to pay for their cell phone. And so then it's your job to combine those into the fixed costs, right? But in this case, I only see one. And so here I'll just put the fixed cost is 10,000. So I'll summarize it here. P is 1,000. C is 250, and the fixed cost is 10,000. So these are a little bit tricky, right? Because there's a lot of wordplay involved, right? Some things are just kind of assumed, and until you've read enough questions, right, it's hard to know what you can assume, and well, it's just hard to be comfortable, right? And so I think you should go through and just kind of try to read as many questions, and even if you don't work through them, right, try to figure out what you've been given at least. Okay? So if we're making a profit function, just for practice, I'm just going to develop that profit function that we did before. I will skip a few steps, right, because it's going to be the exact same as this, right? But I'll just kind of, profit is the total revenue minus the total cost. And the total revenue I can swap out with PX minus, and then the total cost is the VC plus FC, which I'm actually going to swap out for CX plus the fixed cost. All right, skipping straight to that level. And then I'm going to break out the brackets, minus CX minus the fixed cost. Okay. I'll say x is x times p minus c minus the fixed cost. Sometimes it's helpful to pull out the common x's, sometimes it's not as helpful. And so it just depends on what you're looking for. In this case, yeah, it's going to be pretty helpful because we know P, we know C, and we know the fixed costs. And so plugging those in, we've got X times P was 1,000 minus C, which was 250, minus the fixed cost, which is 10,000. And if we simplify this, it becomes 750x minus 10,000. Now that we have this profit function, sure, we can go through and we can find the profit at 12 units, the profit at 13 units, 14 units, 15 units, like I think the question asks. But let's just find, let's start with the profit at 12 units is 750 times 12 minus 10,000. Okay. 750 times 12 is 9,000 minus 10,000. I've got a profit of a negative $1,000. That's not so fun, right? But that's all right. What is the profit at 14 units? Same deal, right? Profit. Now we're going to use X is 14. 750 times 14 minus 10,000. 750 times 14 is 10,500. Phew, minus 10,000. Finally, we're making $500. Notice that when we were selling 12 units, right, we were losing money. Right? When we sold 14 units, then we're making a little bit of money, right? And so what we can do is we can force the profit to be some number, right? And figure out, okay, well, how many do I have to sell in order to reach this profit, right? And so then we're just forcing the profit to be $20,000 in our example, and then we have to solve for X, right? And so it can go both ways. So if we want to make $20,000 in profit, how many units do we need to sell? So we go back to our profit function. I'll just do the general profit of X is 750, oops. 750X minus 10,000. Now, instead of plugging in a value for X, I'm going to force the profit to be 20,000 is 750X minus 10,000. And then I solve for X, right? I bring the 10,000 over to the left-hand side. And so I've got 30,000 is 750, keep messing that up, 750X. So X is 30,000 divided by 750. So X is 30,000 divided by 750, 40 units. even. Any questions about that one? No? Let's do another one. This one's a bit of a thinker, example 103. And there's lots of ways that you can go about and do it. Right, but if you arrive at the same answer, then you did it. Okay. If a company makes $2,000 profit from selling 100 units and $10,000 profit from selling 150 units, what are the fixed costs? Okay. All right. So we only know the profit for each. We know the number of units, and then we don't know anything else, and we want to find what the fixed costs are. So assuming that this is the same company, right? So they either produce 100 or 150, and so the fixed costs are going to be the same, right? Because they're fixed. Okay. And so we're given that the profit at 100 units is 2,000, and the profit at 150 is 10,000. Yeah. So what we can do is, even though we don't know the components necessarily of the profit function, we can still set them up and look at them and see if we can solve the system of equations, right? Because this is going to be a system of equations, right? We're just solving for one thing, though, the fixed costs. Okay. And so, and we want to find the fixed costs, just as a little note. So we know that the profit of X in general is X times P minus C minus the fixed costs. The first equation, or the first statement, I guess, says that 2,000 is 100 times P minus C minus the fixed costs. So that's the first statement. The second statement says that, okay, well, 10,000 is 150 times P minus C minus the fixed costs. Right, and I'll just label these up here, 1, 2 as well. So this one, it is a little bit, it's a bit of a thinker, right? How are you going to solve for these? You have 3 unknowns, right? Luckily, the P minus C is the same unknown in both situations, right? And so however you go about kind of wrangling this thing is probably going to be fine. In fact, there are lots of ways that we can solve for the fixed costs, right? So there are many ways to solve for the fixed costs, including by substitution, right? We can solve for the fixed cost in one of the formulas, substitute it into the other, figure out what P minus C is. The key being treat this P minus C, because they're both variables, treat them as one thing, right? So you won't be able to find what P is and what C is, but you can find, if you treat them as one thing, you can find what P minus C is. And so solve by substitution. Or by elimination. Or even kind of a take on solving by substitution, right? If you set both equations equal to the same thing and then let them equal to each other, right, and things will cancel out. So by setting both equations equal to the same value, and equating them. Okay. Note, we will need to treat P minus C as one variable. So that's going to be key, right? Hanging those two together. And since we've already seen solving by substitution and solving by elimination, right, how about we do the third one, which is kind of a take on substitution, to be honest, but that's all right. Let's do option 3. What if we set each equation equal to 0, right? Let's do option 3 by setting each equation equal to 0. Okay. So the first equation, remember, was 2,000 is 100. 100 times P minus C minus the fixed costs. To force that to equal 0, what I'm going to do, I have to move the 2,000 over to the right-hand side, right? So subtract 2,000 from both sides. I'm left with 0 over here. 0 is 100 times P minus C minus the fixed cost minus 2,000. Same thing for the second equation, right? We had what, 10,000 is 150 times P minus C minus the fixed costs. Forcing it to be 0, I have to subtract 10,000 from both sides. And so I have 150 times P minus C minus the fixed cost minus 10,000. So now, right, P minus C here is the same as P minus C here. We just don't know what they are. Same with the fixed cost here is the same as the fixed cost here. And so what I'm going to do, because they're both equal to 0 now, right, I'm going to say, well, 0 equals 0. You'll agree, right? Which means that this equals this, right? We can cut out the 0, right? Because they all have to equal the same thing. And so what I'm saying is that equation 1 is 0, which is also equation 2. I guess it's not equation 1. Technically. What's my hang up? How about I call it square equation 1? Square equation 2. That part is equal to 0. That was just me being picky, right? Equation 1 is 0 equals this, but then I'm saying equals 0, which is technically true, but I just want to be careful. Which is a square 2. Forcing them to equal each other. Which also means that 100 times P minus C minus FC minus 2,000 is forced to equal 150 times P minus C minus the fixed cost minus 10,000. Oops. Yeah. What we'll find is that when we start collecting like terms, right? So I'm going to move the fixed cost to one side and the P minus C's to the other side, right? And just kind of see what happens. And so I'm going to start by moving the fixed costs over and right, just kind of shifting things over. So I guess what I'm saying is I'm going to move all the fixed costs to the left-hand side and everything else to the right-hand side and see what happens. I think you can already see that the fixed costs are going to go away, be 0, right? Because they're the same regardless of how many units you produce, right? That is the fixed cost. And so it makes sense that they disappear. But we will be able to solve for P minus C. So, without further ado, we've got negative FC plus FC is 150 times P minus C minus 10,000 plus 2,000 minus 100 times P minus C. Did not leave myself enough room. Minus 100 times P minus C. Right. Shifting things over, making drastic changes. So now what we see is 0 is 150 times P minus C. I'm going to simplify the minus 10,000 plus 2,000. So put me at minus 8,000 minus 100 times P minus C. Remember, we're treating P minus C as one thing, right? And so we're going to collect those like terms, and we're going to have 0 is 150, or you know what? I'm going to put the P minus C out front. P minus C times 150 minus 100, and then minus 8,000. All right. So I have 0 is P minus C times 50 minus 8,000. I can slowly pick away at this and figure out what my P minus C is. And so add 8,000 to both sides. 8,000 is 50 times P minus C. Dividing both sides by 50, switching my P minus C over. I get 8,000 divided by 50. P minus C is 160. 8,000 divided by 50. Oh man, 160. Okay. Nice. Okay. So that means that what we're selling them at, so what we're selling each unit at minus the cost to produce each unit is $160, right? So on each unit, we're making $160. Not accounting for the fixed costs, which are coming up here. And so we know P minus C is 160, and we've got some options. Any one of these formulas will work, right? Because now we know, right, regardless of if we're looking here, 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 or here, or even down here, we know that P minus C is 160, right? So what you're gonna do is you're gonna substitute in P minus C into one of these is 160 and solve for the fixed costs. And remember, the fixed cost is the same for all of these, right? Because it's the same company. So it doesn't matter which one we choose. Using P minus C equals 60, or sorry, equals 160, yikes. In any of the formulas above, we can solve for the fixed cost. So for example, using equation 1, the original one, which says that 2,000 is 100 times P minus C minus the fixed costs. I've got 2,000 is 100 times 160 minus the fixed costs. So I've got 2,000 is 16,000 minus the fixed costs. Oops, sorry, 100 times 160, yeah, good. Solving for the fixed costs, right? We can move the fixed cost over to the left-hand side and move the 2,000 over to the right-hand side, and so we get the fixed cost is 16,000 minus 2,000. So our fixed costs must be 14,000. Wowza. Huh? Is that necessarily something that I'll get you to do on a test? No. But is it something that I expect you to be comfortable doing, right? Kind of massaging all these equations to become what you need, right? Yes, I do expect that. Oh, is there anyone who didn't get the formula sheet last day, by the way? All this talk of formula sheets. So these are yours to keep, and then you get clean ones. Was it folded before? I know some of them were. Extras? All right. So if you ever need another one, I've got some here. So even if you just want to borrow it for the class or whatever, if you forget it. Yeah. But like I said, so for the formula sheets, The ones I'm giving you now, those are yours to keep, and then you get clean ones for the tests. But they're the same. Any questions about that one? No? All right. Let's keep moving then. Page break, so. What we saw earlier, right, when we were looking at the profit at 12 units, we had a negative profit, right, which doesn't sound very good, right? Or we could have at some point, right, at 14 units, it switched over to being a positive profit of $500, okay? And so what we're going to introduce here is the shutdown point. Okay, so there's an area in your profit where you're going to have a negative profit, right? But that negative profit is better than the shutdown point. Okay, and so there's the shutdown point. So how it goes in your profit is you start at a shutdown point, then you break even, right? And then after that, you're making profit. Okay? And so we need to be able to figure out, okay, what's the shutdown point? When do I need to stop producing things, right? Because it's costing too much, or it's costing me money. That's not the point. So the shutdown point, oh, I'll write it more carefully. No can do, I guess. The shutdown point is the point where a firm is better off not producing anything at all, right? Just absorbing all the fixed costs and moving on. So the point where a firm is better off not selling or producing. I'll say selling / producing, because remember, we're treating them as if they're the same thing. Producing anything at all. So the shutdown point is when we're not able to cover our variable costs, right? So the variable cost, remember, is the cost associated with producing each unit. So let's say it costs you $5 to print a book, right? And let's say that you're selling them for $4. Would you do that? No, right? Because it's actually costing you money to produce and sell this book. That doesn't make sense, right? And so the shutdown point is when the variable cost is more than the amount that you're able to sell it for. Okay? So if you can no longer cover your variable costs, you have reached the shutdown point. We're not available to take your call. You have reached the shutdown point. So if we break it down, remember our profit function, the profit of X was X times P minus C minus the fixed costs. So looking at this little guy here, P minus C, if this value is less than 0, so negative, is less than 0, right? making it negative, we have reached the shutdown point. We have reached the shutdown point. P minus C is called the contribution margin, right? How much is each sale contributing to your profit, right? That's the contribution margin. And so P minus C is called the contribution margin. It's being a little jumpy up there. So the shutdown point is when P minus C is less than 0, okay, or when P is less than C. Now, this isn't on your formula sheet, right? But it is one worth remembering. The shutdown point is when P is less than C. Because on the test and on the final, I'll ask you, what's the shutdown point? And then it's going to be for any P that's less than C, right? And you'll know C, so then you'll say any P less than C is the shutdown point. Let's do an example, example 104. Looks like this. So a firm's profit is given by the profit function P minus 13x minus 75, right? At what market price does the firm shut down? Okay, so what's the shutdown point? And then taking it another step further, if the price is $100 above shutdown and the quantity produced is 10, how much profit is made? Right. And so we'll have a look at these ones. But first we'll figure out the shutdown point. Okay. And so the shutdown point, we have reached the shutdown point if P minus 13 is less than 0, or if P is less than 13. That's the answer, right? So that's it, you're done. Not a lot of work, right? Because you just need to look at that and say, okay, well, I know if the profit function is set up like this, then I have P minus C. As long as that's positive, then everything's good. As soon as it's less than 0, we stop producing, right? Which makes sense. If the cost to produce each thing is $13, then as soon as the price that we're able to sell it at is less than $13, you don't do it anymore, right? And so now, let the price be $1 above shutdown, and let X be 10 to find the profit. So the shutdown point is at 13, right? We said any point, P less than 13, and so 13 is where we draw the line, right? And so let P be 13 plus 1 then, right? If it's $1 above, so we're gonna let P be 14 now. So then we've got our profit function. So profit of X. Notice that in the textbook, sometimes it's a little sloppy, right? We usually write profit of X, and then I write my X first and then P minus C, but you can definitely write them in any order. That's fine. So the profit of X is, I'll write it my way, X times P minus 13 minus 75. Just as an extra little thing, what's the fixed cost? Just looking at this, we know the fixed cost is 75. Right. So we're letting P be 14 and let X be 10. And we're solving for the profit, so we can let X be 10, P be 14, minus 13 minus 75. Okay. 10 times 1 minus 75. We're going to make a profit of negative 65. Right? That's not good, but it's better than negative 75. Right? And so, because that's your alternative, right? If you have, if you're selling at 13, right, which is the shutdown, 13 minus 13, that's 0, so this is 0, right? And so your profit, if the P was 13, would be negative 75, right? And so even you're going to keep producing, right? Even if you're turning a negative profit, because you have to get through that kind of the red zone where you're going from the shutdown to the break-even point. And the break-even is where your profit is 0, right? So where it turns over from a negative profit to a positive profit. Okay. So just to show, if we had produced 0 units, right, our profit of X would be 0 times 14 minus 13 minus 75, which is just negative 75. Therefore, even at a negative profit, as long as P is above shutdown, we are better off producing and selling products. Any questions about that one? No. Pardon? The shutdown point is 13 for this one, right? But that's where, so the shutdown point is whenever P is less than C. So when P equals C, that's the shutdown point. Okay, let's do another example just so we get into the swing of things. 106. Oops. Labatt's Brewery spends 42 cents to brew a can of beer. The fixed costs associated with producing beer are $450,000. Now, I'm not sure if this is per month or per year, or I'm almost guessing per month, but I don't know. Doesn't seem important. We don't need to know, right? And so what I'm going to highlight here is the cost to produce a can of beer is 0.42. The fixed costs is the 450,000. And the going price for a can of beer is $1.25, meaning the selling price, or P in this case, P is $1.25. So we want to know what is the profit function for Labatt's Brewery, and then we want to find what's the profit earned by selling 10 million cans of beer, and then we're going to find what does the price need to drop to in order for Labatt's to shut down production, right? So essentially, what's the shutdown point? You already know what the shutdown point is. If the price drops below 42 cents per beer, you shut it down, right? So if you're not able to sell it for enough to cover the cost, that's the shutdown point, right? So we've already answered 3, but we'll do it properly. And so we're given, I'll just summarize that information here. Oops. Given that C is 0.42, the fixed cost is 450,000, and P is $1.25. So part 1, we want to find the profit function, and you can do that. You can develop the profit function, right, like we did in the beginning, but I'm just going to jump right to it and say, well, I know the profit of X is X times P minus C minus the fixed costs. Now I'm just going to plug in everything that I know. So that's X times $1.25 minus 42 cents minus 450,000. I can simplify the $1.25 minus 42 cents, but that's about it. Right? And so I get $1.25 minus 0.42. Awesome. 0.83 times X. I move that X around. It's whatever tickles my fancy. Minus 450,000.
So to break even, they need what, 83% of that 4,500? 45 cents. 450.
Sort of, yeah. Because it depends on the number of units, right? X. But we'll get there. And so, okay. Part 2. So this is our profit function. Great, we did it. So now let's use the profit function to find, okay, what's the profit earned by selling 10 million cans of beer? So let X be 10 million. 1, 2, 3, 1, 2, 3. Woo. Find the profit of X. Giving myself lots of room for 10 million here. The profit of 10 million is 0.83 times 10 million. 1, 2, 3. Minus 450,000. This is going to be 8,300,000 minus 450,000. 7,850,000. Hey, that's pretty good profit. You also had to sell 10 million cans of beer, but look at the profit. Part 3, what does the price need to drop to in order for Labatt's to shut down production? So part 3, find the shutdown point. Oops. The shutdown point is when P is less than C. Oh, made a circle. I don't know if I like this new update. So the notability that I'm using, if I hold it down or if I do something, it tries to make a shape out of whatever I drew. So it turned my C into a circle. I'm not sure if that's helpful. There. So that's the shutdown point, right? And so we need to know what C is, right? And then we just leave P as it is. So when P is less than 42 cents, we shut it down. So that's the answer. That's all you have to do for that one.
Be less than or equal to? No.
It can still be equal because then it goes to 0, right? And then you're just fixed. You've got your fixed cost, but you're not losing more money besides the fixed costs, right? So 0 is still okay, but anything less than 0.42, no more. Okay. So any questions about that? Just the stretch. I see you. All right. So we've been talking about, okay, so we've talked about the shutdown point, and then I've mentioned a few times that we have the break-even output, right? And so what we're going to talk about is, okay, break-even is when profit is 0. How many things do I need to sell in order to make a profit of 0? And rather, how many more things do I need to make, right, until we make good profit? That didn't really make sense. Don't listen to me. Well, at least that last part. Let's talk about the break-even output. Break-even output. Output, remember, is X. Okay, so the number of units. It's the number of units X needed to get to a profit of 0. Right. So the break-even point is when the profit is 0. Break-even point is when the profit is 0. Okay. And the break-even output is how many units do I need to sell to get to a profit of 0. Okay. And rather, right, at least how many units do I need to sell in order to make a positive profit? That's what I wanted to say. Just wasn't coming out. We already did this once, right? We forced the profit to be 0. I think we did. Can't quite remember, but at some point, I think we forced the profit to be 0 and solved for X, right? Or something similar. We forced the profit to be 20,000. I remember that. And then we solved for X. Same idea. So let's do example 108. It's on the slant here. Suppose that the price of a good is $25 and the total costs are given by 85 plus 24x. That's another way that we could have this thing come together, right? What's the break-even level of output? So this is what I mean by kind of getting to know your profit function, because then you're not thrown off by things like, okay, I know the total cost, right? Because then you just know where to step into your profit function. And so the first thing I'm going to do here is well, I guess I better list what we're given. We're given that P is 25 and the total cost is 85 plus 24x. Find X when the profit of X is 0. This is what we mean by the break-even level of output. Just a note about when you're writing this, the first test, right? There's going to be stuff like this on there. Even if you don't, if you're completely drawing a blank and you don't know what your profit function is, you can still develop the general profit function, and you can show me that you know things like, okay, well, what would you need to do to solve for the break-even level of output? Even if you're not able to solve for it specifically, right? Telling me that you know that you have to solve for X when the profit is 0, right? That's worth something, and I can not give you a lot of marks, but I can give you some marks for that, right? And so, so it's always good to be able to just tell me everything that you do know and just show off everything that you know to do. You know? So for here, because I have that total cost, right, what I'm going to do is I'm just going to start from the top of our profit function. Remember, we wrote the profit of X is the total revenue minus the total cost. And then from here, we swapped out, okay, well, total revenue is P times X. And then now, instead of plugging in our total costs, right, I'm given the total cost is 85 plus 24x. And so I'm going to plug that in instead, 85 plus 24x. But also, if you're given the total cost is 85 plus 24x, what's the fixed cost? 85. What's the variable cost? 24x. What's the cost to produce each item? 24. Right? And so you have all that information. P is 25. Right? So I'm going to plug that in. So 25x. And then I'm going to expand this bracket here, minus 85 minus 24x. I can just simplify this. So 25x minus 24x is just x, and then minus 85. So that's our profit function when P is 25. And so now set the profit of X equal to 0, then solve for X, just as a little reminder of what we're doing. So we're setting 0 is X minus 85, so X would be 85. Therefore, we would need to sell / produce 85 units to reach the break-even point. Okay. So we would need to sell at least 83 units to have a positive profit. To have a positive profit. How about another example? 109. Oh, it's really on the angle here. Whoa. Let's see if it's this window or the other window. It doesn't really.
Lines just suck.
Yeah. Don't really do anything, do they? But it's definitely this window. It's just weird. Sorry, guys. It's hard to see.
85 minutes.
Sure do. Hey, never happened. Nothing to see here. Thank you. That would have been very confusing for someone looking back. Yeah, nothing happening here. All right. Let's do example 109. Suppose it costs $75 per minute to run a TV commercial during sporting events. Furthermore, you've determined that revenues from these TV commercials amounts to $125 per minute they air. Okay, so that's good. The total cost of creating a TV commercial is roughly $15,000. How long do you have to run your commercial in order to break even? Okay. And so they say total cost, but they actually mean fixed costs. And that's just kind of implied because we've got the variable cost of $75 per minute. And so here, this guy is actually referring to the fixed costs, right, the total costs. And it's more a matter of context, right? What do we know? What do we not know? And so we've got the cost to run or to make, to run a commercial per minute is 75. And we're told that we essentially sell these minutes at 125. So P is 125, right? Because those are the revenues, right? So that's what we're getting off of each minute. And then here, the 15,000 is your fixed cost is 15,000. So a little bit tricky just because of the wording. But once we get past that, it's not really a problem. So we're given that C is 75, just summarizing what I highlighted up there. P is 125 and the fixed cost is 15,000. How long do you have to run your commercial in order to break even, right? And so what we need to do is we need to find our profit function, set it equal to 0, and figure out what X is, right? And that'll be the number of minutes that we need to run it for in order to make 0 profit. And so we've got our profit of X. In general is X times P minus C minus the fixed costs. Just looking at things that I've been given, I can use that formula. Or I can develop it like we did in the beginning. X we don't know, but I know P is 125 and I know C is 75 minus the fixed cost, which is 15,000. 125 minus 75 is 50. 50x minus 15,000 is my profit function. So now we can find the break-even level of output by setting the profit of X equal to 0. So doing that, I see, okay, 0 is 50 times X minus 15,000. Solving for X, right, I move 15,000 over to the left-hand side is 50X. So X is 15,000 divided by 50. So X is 300. Which means I need to run my commercial for at least 300 minutes before I even start seeing a positive profit. Therefore, the commercial, was it a commercial? I think so. Yeah. Phew. The commercial must run for at least 300 minutes in order to break even.
5 hours.
It's a long time. Especially because commercials, they're not that long, right? Quick little things. 30 seconds maybe. I don't know. I don't know how long a commercial is. I guess it varies. But anyways. So we developed a profit function. We talked about, okay, well, how do we manipulate this thing, right? We can solve for X, we can solve for the profit. We can even solve for fixed costs like we did, or P minus C. We talked about the shutdown point, which is when P is less than C. And we talked about the break-even point, which is when we force the profit to be 0 and solve for X. That's a lot of stuff, right? But don't worry, you'll see it on test 1 and you'll also see it on the final exam, right? So it's going to be another long answer question on the final exam. Okay. Any questions? No? Then that's all I've got for you today. So I'll see you on Tuesday. We were speedy today. I can feel it in my wrists.